Hey everybody, I hope you were able to understand the first section on prisms and cylinders. If you did, this will go a little bit easier. So if you're not quite getting that last one, then send me some messages and we'll try to work you through it. But this will be a lot simpler. The next section, understanding that. I will say of all the different shapes we're going to look at, probably the pyramid can be the trickiest one. Even the cone a little bit for one little thing. Okay. So there's a couple problems sometimes that are a little tricky, and that trickiness requires you to use the Pythagorean theorem, okay? So we'll go over that a little bit sometimes. All right, I think you know what a pyramid is. I think you're familiar with that idea of what it looks like, except for a couple things. It is a three-dimensional, it's again that polyhedron. But in this case, the sides, the faces, are all going to be triangles, unlike a prism where they're all rectangles. And the pyramids are named for their base. If we call it a square pyramid, it's because it has a square. Rectangular pyramid, it have a rectangle. It's actually possible to have a triangular pyramid. You'll see that in some of the problems here in examples. So, that's where the name comes from, and that's what the shape is. It's about the base, okay, the base. Now, the sides will still be triangles. What we think of as the pyramids in Egypt are all square pyramids, actually perfect squares, okay? And so that's what we're going to look at here in terms of pyramids. So a little bit different formula, but very similar to be a plug and chug, except for one thing. First of all, the surface area formula, you might want to write this down. You might want to pause and, write down, here's your formula, okay? And then here's what things mean. Now, you'll notice some similarities. That's why I said if you're having trouble with the previous one on prisms, you're going to have trouble with this. But there is a B, an area of base, and P, perimeter of the base. So it's found the exact same way. Okay. The only thing new is that this is actually an L. A lot of times you would see it as a cursive L. It would look something like this. That's like a cursive L. Actually, there should be a little thing here like that. Cursive L, but L is the slant height. Okay, I don't know why it's L. Maybe in ancient Greek, the word slant started with an L. I have no idea, but this is what the slant height is. The slant height is over here. It's this height of this little triangle on the side. So that's our slant height. Okay, and so that's what will have to be given to you in order to find the surface area. All right. Okay. So, like I said, you might want to pause this and write this down before we do the example. All right. So, oops, hold on. Sorry about that. Yeah, try this again. So, sorry about that. Surface area of this pyramid, of this square pyramid. Let's make that a little bit bigger. All right. Hopefully you can see that. Actually, I'm going to make it a little bit smaller. Sorry. Having a little bit of issues here. So this is a square pyramid. All right. And so we're going to use our formula. Surface area is going to be B plus 1/2 P. And then I'm going to write it as a little cursive L there as the L. Okay, so the first thing we need to find is the area of the base. Well, if it's a square, all sides are 5. So you're going to go 5 times 5, or 25. Okay, P is the area of the base. Well, they're all 5. So 5 plus 5 plus 5 plus 5 is going to be 20. All right, and then L you can see is given to you. It's this little thing here. There's a little right angle there usually. L is going to be 7. All right, so then we just have to plug in. So that's 25 plus 1/2 times 20 and times 7. Now, again, you can type this all in one shot. You can kind of do it in pieces. If I do it here in pieces, the first thing I would do is 1/2 times 20 is 10, right? That's going to be 10, all right? And then 10 times 7 is 70. All right, so this gives me 95, and we're dealing with feet, and that's squared. So surface area is 95 feet squared. All right. So this is because it's a square base. If it would have been a rectangle base, I would know another side over here, and we would figure that out the same way we did with previous ones. Okay, notice very similar to what you did with prisms. Okay, just a little bit different formula. You got that 1/2 you got to be careful of. You could change it on your calculator to 0.5 if you wanted to. So you'd go 25 plus 0.5 times 20 times 7. It would give you the answer of 95. All right. So the next problem, or the next thing we're going to talk about is the volume. Notice this formula here, 1/3 base times height. This is almost exactly the same as the prism formula. The prism formula was just base times height. So the same letters, same things, except it's 1/3. So a pyramid is 1/3 that of a prism of the same height. All right, so the height now is not a slant height. It's inside here. It is the height of the pyramid, straight up and down, and this will be in the dead center. So this one's a little bit easier because it's nothing new. All right, so again, you might want to pause, go back here and pause this so you can write down that formula. Okay. All right, so the volume then of a pyramid, pretty straightforward. Okay, especially if I give you the information like this, 1/3 base times height. So my base, well, this is a square pyramid again, so it is 8 times 8, or 64. Okay. Oops, I don't need that other equals. And then my h in this case is 9. So I'm just going to plug in to our formula here, and we're going to say 1/3 times 64 times 9. Okay, and type that all in at one shot. A couple different ways we could do this. One, we could multiply 64 and 9. Leave the 1/3 there. This gives me 576. And then what you could do is you go 576 divided by 3. That might be the easiest. Don't necessarily change that to a decimal. Leave it as 1 divided by 3. So, you know, the other way in a calculator, if you were going to type this as is in a calculator, I would go 1 divided by 3 times 64 times 9. That would probably be the best way to do that. Okay. Either way, when you're all said and done, 192 were feet, and its volume, so it's cubed. Okay. So volume of pyramid shouldn't be too bad. All right. All right. So what do we have next? Cones. I know I changed the colors here. These are some different PowerPoints I've used over the years, kind of put them together, and so there's some strange colors. The reason we do cones with pyramids, they're kind of like a pyramid with a circular base. So again, these are easier, except for one little thing, which we'll see. And I'm going to give you both formulas at once, so you might want to pause this. Notice the formula is, for the surface area, is pi r squared plus pi r l. L, again, that's my L, is my slant height. Okay? And you can see it right over here. What's missing here on this picture is this would be my r, right? That's my radius, and h is my height. What I want you to notice is this forms a right triangle. So that's why sometimes we may need to use the Pythagorean theorem on this. In fact, there's a couple examples I'm going to ask you to do that. Use the Pythagorean theorem to find the slant height. We'll do it here with an example. Again, you may want to pause so that you can get the two formulas written down. All right, so this should be V equals that one. All right, okay. So let's look at some examples here. And here's an example. This is a surface area problem, right? So surface area, again, pi r squared plus pi r l. Well, here's the problem. I don't know L. It's an X. All right, I got to find it. All right, so how are we going to do that? Well, we're going to use the Pythagorean theorem. All right, and in this case, this slant height is X. We're going to call it X. What is that in terms of the right triangle? Yeah, it's my C. Remember, your Pythagorean theorem is a squared plus b squared is c squared. So 5 squared plus 12 squared, and we'll say x squared in this case. So that's 25 plus 144. This is 169. And remember, you take the square root of that. So x is 13. So that means my L is 13. My R is 5. I don't need the H for the formula, but I needed it to find my L. So then from there, it is just a straight plug and chug. Pi 5 squared plus pi times 5 times 13. Okay, so this is 25 pi plus What have we got here? 65 pi. We could do it this way. You could also just type it in. Remember we talked about that in the cylinder problems. If we didn't, it's 90 pi. And then for surface area as a decimal, which is what I want for these, in 2 decimal places is always fine. 281.74 feet squared. Okay. All right. So next one, last one, would be a volume problem. And we may have to use the Pythagorean theorem, but in this case we're not going to. The formula here again is 1/3 pi r squared h. Well, we can see my r is 6, my h is 10. Okay, so just plug in. This is a regular plug and chug. So 6 squared times 10. If we wanted to, we could break this down. We can just type it in as is. This would be 36, right? 36 times 10. I'm just going to write it up above here. So that's 360. What you could do is go 360 divided by 3. If you did that, you get 120 pi. All right, but as a decimal, if we typed it all in one shot, 376. 0.99 is what I have here, and it is meters cubed. Okay, again, I'm going to give you a worksheet. There are going to be a few problems that I'm going to ask you to find the slant height. So that's just a Pythagorean theorem problem. You don't actually have to find, so follow the directions. The other problems would just be straightforward surface area volume problems. Trying to think here. Yep, that's it. Okay, all right. Take care and try out some of those problems. Let me know if you have any questions.